Welcome back. I have a short video here for the Gravity Force Lab, Newton's Universal Law of Gravity or of Gravitation. And it's a PhET lab, a PhET. And you need to complete all the tables and so on. So you have to follow this through. So remember the force between any two masses is G, capital G, the gravitational constant, M1, M2 over r squared. And we have this here, so I'm going to copy the link and paste it into my browser and open the app, open the website. And so let's see what we get here. So Control V, enter, and let's see what we get. So okay, so we have this. So let's look at the table here. It says in part one, changing the masses while keeping the distance between the two masses constant. So place M1 at 0 and M2 at 5 meters. So let's see. So here's, okay, so here they are. They are center to center, they're 4 meters here. So make them 5 meters. And let's take the sound effects away. And this is the force between them. Let's view scientific notation. It's just easier to view. So it says the force between the two masses is 1.07 times 10 to the minus 7 newtons. Mass 1 is applying a force on mass 2, and mass 2 is applying a force on mass 1, like that. And let's do one part of this table. So the radius will stay 5. And let me do just this one here. So when M1 is 70 and the other one is 40. So when M1 is 70, so I can just decrease it to about 70. Okay, and the other one is 40. Let's go to 40. Okay, 70 and 40. And let's see what the force between them is. It says the force is 7.48 times 10 to the minus 9. So I will write it here. 7.48. I'll put e minus 9. So that's e times 10 to the minus 10 times 10 to the minus 9. Yeah, and that's what I will do. Okay, sounds good. And then the product of the two masses, m1 times m2, well, 70 times 40 is 2,800. Okay. Once you complete this table, you're going to make a graph. It says here plot the force on the y-axis, so the force, and the product of the two masses on the x-axis. And then it asks you what's the shape of the plot, and it should be linear. And then you will fit a line through the data points, and then you see what you get. And then it says here, it says using the slope of the line and r, calculate g. So you will calculate that. So after you have completed all this table, and you're asked a few things. Now, in the next part is you're going to keep the masses constant. Both of them will stay at 10 kilograms. M1 will be at 0, and R will be at 2 meters. So let's see. M1 will be at 0, and M2 will be at 2 meters. Let's see. So 2 meters between them. And both of them, I believe we said it's 10. Yeah, both of them will be 10. Yep. So both of them will be 10. So let's slide it all the way to 10. Let's slide it all the way to 10. So both of them are 10. And so we're going to keep the masses constant, but we're going to change now the radius. Okay. So since the masses are 10 kilograms, so this will be 10 throughout. Okay, 10 throughout. And what's the force? Let's just do the, in fact, let me do the 9th one here. Still, the masses are still 10 kilograms. And what's the force on this one when r is 9 meters? Let's see what the force is. When r is 9 meters, let's pull it all the way. It doesn't get all the way to 9 meters, so I guess we will have to stop at 10 meters, or um, let me change the masses to um, 100 kilograms each. I would change them to 100 kilograms actually for the lab, for this part. And so let's change them to 100 kilograms. Okay, let's put them at 100 kilograms each and see if it will accept that. If it does, we'll just change it to that. Let's see if we can. Um, oh, I see. Okay, yeah, let's pull this person this way and then this one this way, and now it's fine. So it's 90. Okay, let's change it back to 10 and 10. Okay, so they were not, this person wasn't all the way to the left. They can be as far apart as 10. So, okay, 9, what's the force? 8.24 times 10 to the minus 11. 8.24 times 10 to the minus 11. So we'll keep the masses at 10. So we're going to keep them at 10. So, and I forget what I said. 8.24 times 10 to the minus 11. So 8.24 e minus 11. And then here it says, what is 1 over r squared? Well, what is 1 over 9 squared? Well, we can use the calculator. 1 over 9 squared, that's 1 over 81. 1 divided by 81, and that's 0.0123 4, 5, 6, 7, 8, 9, 0.1234567. In practice, you will go to Excel and actually do this. You will go to Excel and do it. That's much easier. So anyways, I wrote several digits here. So, and then you're going to plot the force versus R, and then the force versus 1 over R, and you will fit a power or and here it would be linear. And then you have some questions here to answer. And that's about it. Let me make it brief.